Hey, what's up, guys? This is for college prep math. This is part of our series on number theory out of the ACT preparation sequence. And in doing that, some of these questions that pop up on the ACT document, which, by the way, this is a good document for review for Algebra 1 and Algebra 2, determining the greatest common factor of an expression. So we have an expression, we have three of them. We want to find out what is able to divide all three of these. What's the biggest thing that can divide all three of these? Turns out there's probably 5 or 6 random combinations of things, maybe more, that can divide these, but we want to find the most expansive, holistic one that can do that. The way to mess this question up, the way to solve this one is to actually think about breaking the question all the way down to its basic components. Let's start with 56xy squared. 56xy squared. Let me focus on the x and the y last. I guess I was thinking of them first, but in the moment, I'm going to decide. We'll leave this for the end. Let's really focus on the 56, just the number 56, and let's prime factorize it. So 56 is even. If you divide 56 by 2, because it's even, we're left with 28. Yeah, 28, right? The 2 times 28 makes the 8 become a 16, blah, blah, blah. Check your calculator. Now, if 28 is what's left after we divide by 2, then let's talk about the 28. Is the 28 even? Well, yeah, it is. So we can divide further by 2. That leaves us with 28 divided by 2, 14. Turns out 2 times 2 times 14 is also 56. So breaking them into pieces. 14 is where we are right now. Is 14 even? Sure it is. 14 divided by 2, you're left with 7. 7 is a prime number, so we're done. Now let's look at the x and the y. Done. We're done with the 56. We got to finish the problem out. X has no other thing with it, so we're just going to write the x all by itself. Y to the second power. It's important to recognize this, that y to the second power means y times y. Now we have no exponents. We've fully broken the entire expression down into its components. It's like taking a molecule in science and looking at its atoms. Let's do the same thing for 18x squared y squared. So 18x squared y squared. If I look at the 18 first, right, save x squared y squared for the end. 18 is even, so divide by 2. Dividing by 2, we're left with 9, and then 9 is 3 times 3. Now, x squared y squared, there is 2 x's because of the squared, and there's 2 y's because of the squared. That's a squared for the x term, and then y has its own term that's squared. Now we've broken it down. We've broken this expression, 18x squared y squared, fully down into its atoms, into its primes. And so there it is, 2 times 3 times 3 times x times y times y. It would be ridiculous to write that way all the time. It's good to know what it's made of. Now we have 6x, but there's a squared on the outside. And I chose this problem, or I rewrote this problem to include, what do you do with the squared here? I guess, technically, the squared is making both of those change. So this is really 6 squared x squared y. That's the expression, 36. Now let's break that up. Although, if I think about it, I didn't really need to break this or to move the 6 into the 36 level. So it's good. I can just think about prime factors of 6 twice. 6 is, let me write the expression down here. 6 is 2 times 3. So the fact that it's 2 times 3 means I have 2 times 3 squared. So it shows up again, times 2 times 3. That's the prime factorization. It's a little out of order. You know, we should put all the 2's first because presumably that's how we could have done that up here. We could have gone a different direction with 56. We could have divided by something else. Like we could have divided by 8. And then broke the 8 up because we can divide by the divisors. We can figure out what the divisors are and then look at what's common at their atomic level, their prime level. So here we have 2 times 3 times 2 times 3. That's the 6 squared. Then we have x written twice because it's x squared with the way that it's set up. And then we have just a single solitary y. If you look at the prime factorizations, what's common amongst all of them? Let's see if I can highlight this. We have 2's, no 3's in this top row, so 3's are out. I know there's double 3's, but there's only 1 2 in the 18. So for that reason, 2 is the number that is the greatest common factor. Now we look at the x's and the y's. 1x, so there's at least an x in all of them. And then even though there's multiple x's in the second two expressions, there's only one x in the first expression, so that's it. Looking at all the y's, two y's, a single y. All of them have a y, but they don't have more than that. Some of them have more y's, but this last one only has the one y expression. So what's common amongst all three is just that y value, which means, survey says, 2xy is the GCF. The greatest common factor is what's common in all of these three expressions. Thanks for watching this video.